Okay folks, Jared Buckley is my name. I'm Programme Manager for ESB eCars, and I'll give another perspective on electric vehicles, and it'll be based on our own experience here in Ireland, where we've been trialling eCars now for about the last 18 months on a programme that was sponsored by the Irish Government that asked ESB to support a pilot project out to Q1 2014. A pilot project that would look at the installation of a low-level electrical infrastructure around the country that would involve home charging connections, on-street public charging, and DC fast charging based in petrol stations. And we also have about 30 or 40 e-cars that we use and we give to what we call e-car ambassadors, to try to get a user experience, to get the sense of it. And I can tell you at this stage that most people that have driven an electric vehicle are absolutely overwhelmed by the technology in it, by the feel, by the acceleration, by the comfort, It's not just an electric car anymore, it's a very, very smart piece of technology, with a lot of sat-nav, a lot of GSM, a lot of intelligence in it. The Nissan Leaf has a most fantastic iPhone app, that you can kind of program your car before you ever get into it the next day. So I hope to give you some appreciation, and also maybe, hopefully, give you a few pointers that will address some of the very important challenges that Vernon laid down around, maybe 55% lost before you even charge the car with electricity. Because the Irish model really isn't just about electric vehicles, it's about renewables. We have a huge amount of wind in Ireland, both at the moment, classically and historically. We have a very, very comprehensive wind installed infrastructure now where we're generating an awful lot of megawatts from wind. The difficulty is where do we use them at night? And this is where EVs will provide the answer. And if you can put a smart grid, which again is entirely available now, but not fully implemented, using ICT technology, mobile phones, where the grid can either, regulate or attenuate the rate at which a car is charging during the night, maybe even turn it down if a power station trips somewhere, or maybe like they're doing in Japan at the moment, where, if you take a small estate of houses that might have 6, 8 or 10 electric vehicles in it, there's enough power, there's about 24 kilowatt hours in a fully charged battery. It can actually run the estate of houses for 2 days during a power outage, by going from what's called vehicle to grid. So I hope to give a kind of an interesting perspective on where we are in Ireland, a trial that we're rolling out at the moment. There's other things happening beside all the financial bad news at the moment. Somewhere out to 2020, the EU plan a lot of carbon taxes, which haven't fully kicked in yet. But the Irish government has set a target of about 10% of all vehicles to be electric, by 2020. Given our current volume, we're a very car-hungry community of 4 million people. There's an awful lot of cars on the Irish roads. That's about 250,000 electric vehicles by 2020. EU Renewables Directive, drive this move as well, even though I know it's quite slow, even at 2012 where we're at the moment. And again, this climate world strategy, around Kyoto and other protocols that haven't been fully implemented, they're not all the time just going to keep going away, and you'd wonder what Barack Obama will do now, given that he's in for a second term. Will he seriously look at environmental issues? And again, they all impact on tax, on carbon, on cost, and on energy. So, notwithstanding that, Ireland, apart from any other jurisdiction, its position on the western coast of Europe, the fact that we are quite a small island, and I'm sure all of you in the room have experienced by now, with the motorways between Cork and Dublin, Dublin Athlone to Galway, north to Belfast, it is very, very easy now to get anywhere in the Irish jurisdiction. And whilst Vernon again laid down some challenges about range, it's interesting that as part of this trial, one of our e-cars users seems to have found a way past one of those laws of physics that Vernon gave us a very interesting cubic equation on, where the drag is proportional to your velocity squared, this individual has found an answer. So while I'm speaking, I challenge you to try and, what is that answer, you know, where he has increased the range of a Nissan Leaf from about 160 kilometres up to 220. So we'll see, you know, whether he was serious or not, but this is what he blogged anyway, and he claims he did find the answer. So like in Ireland, we have the advantage of a single network. It's a small jurisdiction. We have government commitment. We certainly did have strong commitment anyway when we had the PDs, but like we had the government make a call on this. We have high levels of wind generation. We have limited range between urban centres. We have a very good climate for batteries, despite the challenges that Vernon outlined for us. We have high levels of single family dwellings, and you mightn't think that that's significant, you know, but try and implement EVs in Berlin, you know, where 50 to 60% of the population live in apartment blocks, or in the centre of Holland, you know, in Amsterdam, where there's no space. Here, like, most people live kind of either in the countryside or in estates where you can park in front of your own house. And for electric vehicles, it's great to have that luxury where you can plug in to your own house at night and use night rate electricity. We are also a leader in the IT sector, like, and we kind of partner Intel and all the big IT companies on this project, you know, to try and solve, you know, the full range of problems, you know, from IT, comms, meter management systems, meter settlement systems, apart from the comms associated with driving, etc. Okay. So, as I said, we have already invested hugely in wind in Ireland. We have a very, very comprehensive installation of wind generators. And like, if you take it that the wind generator, literally, I know Vernon made the point that but he did qualify it by saying, if we take conventional generation, your losses are at least 55% before you start. But on a wind generated system, like, it will generate zero carbon electricity at night. And if we can use that at night when we generally have a lull in the transmission system and use it to charge a battery, you know, it is an ideal solution. So I'm not trying to propose that EVs are a solution to anything, but if you take it with a jurisdiction like Ireland with a lot of wind, with a lot of spare capacity at night rate electricity, with small inter-urban distances, you are moving towards a fairly kind of clever solution that sort of merges across a number of horizons. Again, you see our typical valley at night and a typical peak during the day. So, like, there is capacity there are opportunities, and as I said, it's a solution that's particularly amenable in this jurisdiction. Sort of moving on, all this slide emphasises is that to realise the full benefits of electric vehicles, to realise the full benefits of a lot of available cheap night rate clean CO2 wind, and then to sit a sort of an ICT layer with smart technologies down on top of it. This is, again, sort of very amenable to the brand that Ireland wants to kind of place on itself, you know, that we're up there with the best, you know, in terms of the basic technologies, in terms of computing and in terms of communication. And it will mean that, you know, if it can be realised in time, in the full, you know, you could go from a jurisdiction, you know, where we use a lot of wind at night, where we charge cars on zero carbon generated electricity, where they then drive around during the day emitting zero carbon emissions. And I know there's this point, like, people think of it all the time, what if I want to drive, you know, to Donegal, or what if I want to drive elsewhere? And again, some of the challenges that Werner, which correctly laid down, is, like, you can now DC fast charge your Nissan Leaf or your Mitsubishi IET in about 25 minutes, okay? And, like, if you take your service station now on your motorways, that's not an unreasonable time if you want to pull in to get a coffee, to get a sandwich, to use the loo. That, you know, you can have 80% full charge DC injected into the car, and I'll show you one of those chargers later on. So that does make your inter-urban distances a lot smaller. Now again, and like, I suppose it's illustrative that Vernon still laid it down as a challenge about these distances, because when the current batch of electric vehicles came on the market, you were allowed DC fast charge once a day, you know, because of the, you know, the charging cycle and the discharging cycle. Nissan Leaf now, or Nissan, and Vernon mightn't know this, have now removed that restriction based on their experience here over the last 2 years, rightly or wrongly, but they are guaranteeing the battery for 5 years. So I don't think they'd remove that restriction lightly if they thought it was going to impact on a 5-year guarantee on the battery. So you can now DC fast charge, like if you wanted to go to Dublin, you could DC fast charge in, say, either Cashel or Monasterevin in Junction 14. So that to me again is an indication of the confidence, once you get usage, once you get users, where this technology will continually improve. We were having a discussion outside about having a cup of tea about, how do you plug into these? There's a whole new sort of technology about types of connectors. The very first cars had your ordinary 13 amp socket, okay? These ones have a different type of much heavier socket. Like this is actually a 3-phase Menike socket. It has an RS and T phase, it has a neutral, it has an earth. It also has 2 pilot wires that communicate with the car to sort of establish under a kind of a mode of charging which says, I'm an electric vehicle. It sends a pulse width modulated signal to the car to say what sort of charging current can it take. Can it take 16 amp single phase, 32 amp? Can it take 3 phase? The next batch of Renault Fluences, which are on sale in Ireland at the moment, either the next batch or the second next batch, will be capable of taking 3 phase, 32 amp. Okay? So rather than taking 6 hours to charge, you'll now be able to charge it almost to 80% in about an hour. So like even in the short time of our project here, where things are moving on at a pace, and we would hope like that the bigger challenges that were outlined, we will find ways of overcoming them. So like you have different, like mode 1 really is your old classic AC charging. You just plug it in and the power is on. Mode 2 is a slight improvement on that, but there is some communication. Sorry, mode 2. Mode 3 has the kind of current IEC Senelec standard communication. So that like if you plug into a mode 3 charger, you won't get any power. But what will happen is the charging unit will start communicating with the car. When it establishes the right criteria, it will then close the contactor and power is on. So you can't just walk up to one of these things in the street and get a shock off it or anything. It's not live until the proper protocol is established. Mode 4 is your DC charging, okay? And for people in the room who mightn't fully appreciate this, the first 3 cars, for AC charging, the AC charger is on board on the car. And all you're doing is presenting it with your normal 220 volts. The DC charging option is onto a separate terminal in the battery. It's onto the DC terminals. And generally, the AC is converted to DC in a separate standalone biggish charger. It's about 50 kVA, okay? And that's where you get your much faster charging in a much shorter time period. And I'll show you 1 or 2 photographs of those also. So like, this is the pilot signal that sort of communicates with the car. It sort of starts off at 12 volts. It says vehicle not connected. You plug in your vehicle is ready to charge. Your pulse width modulated signal will drop to 9 volts. Vehicle request charge, it will drop again. And then this is where, you might get a power reduction command from the grid. Supposing the grid wants to attenuate the load, and rather than starting another power station with CO2 implications and cost, it could say, you could have a tariff for your EV car to say, I'm prepared to accept interruptions, okay, or I'm prepared to accept attenuation, and the grid could turn the charging from 16 amps down to 8. Now that sounds trivial enough, but like if you have a population of a couple of 100,000 cars, that's hugely significant for the grid operator, and hugely significant from an energy management point of view. So like, the whole thing is beginning to get mixed up now. Like you had single car units under the old diesel model. Now the whole thing is becoming sort of integrated in a sort of a, first of all, at the moment, in a simple one way, from the transmission system down to the distribution system down to the car. But it brings other opportunities, where, you are now beginning to control the demand profile. You're able to reduce your spinning reserve, because some of your spinning reserve now is the control of battery charging from a grid to car point of view. You're able to manage trips, and you have a different option now on frequency control, and you are forced to bring in interruptible tariffs for drivers, For, you might wake up in the morning, you might have a message in your phone from ESB, sorry, your car isn't charged, you know what I mean? There's a few bob in your account for a taxi, and you just take it on the chin. But look, hopefully it won't come to that. But there's another option then, where you'd have an import-export tariff, where, again, if your trip the next morning wasn't mission critical, you might accept that your car would be used to export power back, and your car now becomes a kind of a storage plant for electricity. So we're a good bit away from exploiting some of that at the moment, but it is an inevitable consequence. And this is where things will move in the medium term. And we always underestimate how kind of fast we get to this. And even for battery second life, like Vernon correctly outlined again, batteries are a whole technology in themselves. But up to about this point in time, battery technology was never seriously looked at. When you think about the first vehicles were electric, in the pre-1900s, how have we gone another 100 years and that technology hasn't moved on hugely? But can you imagine if we apply the knowledge that's available now, with a return? I suppose the interesting thing for me is that there is no major car manufacturer in the world at the moment that doesn't have an EV vehicle program. Like Ford's, Toyota, BMW, Audis, they all have them. Now, I don't know, do they see something coming down the line in terms of energy, or petrol, or CO2, or whatever? But they are all in the EV business for some reason, okay? And we just have to wait and see. Again, secondary, the availability of batteries, because we know well how a battery degrades, in the first few years of its life and where it goes. But again, there is other storage energy, electrical energy in particular, especially if it's generated by wind for free and for CO2 free, to use them in some sort of a storage medium or mode. And again, they can be, you can justify the lifetime return on the asset. So in particular, electric vehicle standards, I've worked on a small number of standardised committees that work at IEC and Senelec level, and it is always slow to get, full international agreement. In Germany, they want a particular type of plug and socket. The French, Italians have their own view on it. There is still no full EU agreement. But certainly what you don't want to happen is that your electric vehicle won't be interoperable, okay? If you want to plug your mobile phone or your laptop in France or the UK or Germany or the US, you need to go for a different type of interface. So we hope it won't go to that, but it will be a bit slow. But what you see there are some of the, where we are at the moment in terms of technology. A lot of the comms system are working and working well. The metering billing systems, we're doing a project with IBM at the moment, an EU-funded project and stuff like that. A lot of the hardware is currently available, okay? There is over 1,000 charge points in this country at the moment that we've installed as part of our project. And there's over 500 on-street available, and there's about 25 DC, okay? So, it is possible to do these things, and what we're trying to do is increase the confidence that people will consider moving in that direction. So there are some standardization challenges. The big answer, I think, will be around DC fast charging. If you go back to what Vernon said about power stations and using power station generated electricity during the day, I'd agree with him 100%. The last thing for this equation to work is for someone literally to plug in their car during the day. They should really be plugging it in at night and charging overnight. But something mightn't happen in the car, some timer mightn't work, and you might be driving a lot of miles in the day, and for range anxiety and other reasons, people will have to have the confidence of being able to charge somewhere during the day. We're doing a project in the with Topaz and with the major petrol suppliers, and we site chargers around the country on the motorways. They're in Enfield, they're on the M1 as you go north to Dublin. This is typically what they look like. This here is an AC charger. The current cars on AC will just take single phase 16 amp, which, as Vernon asked me, takes about 6 hours for a full charge, okay? But if you could go from 16 amp single phase to 32 amp 3 phase. On the one AC charger, you can go from 6 hours down to 1 hour. Okay, that's just the simple sums of it. And like that AC charger that we're installing is capable of 32 amps 3 phase, even though the car at the moment will only take 16 amp single phase. So that charger is kind of future-proof. And you can plug 2 cars into it, you know. This one is a DC charger where all the, you know, the rectification from AC to DC is done in this unit here. And I'll just show you a different graphic of it here. It injects straight into the car at DC. So the car that you see being charged there, there's two connection points, one for DC, one for AC. But that car will take only 25 minutes to go to about 80%, from 0 to 80% full charge, which is pretty good, you know, at 2012, when we're still fairly early on in the project. We've got feedback from our own users that are on this demonstration project that I know from driving an electric vehicle myself, it has incredible acceleration. Like if Vernon was to throw up some of his slides again, you know, the actual power output, you know, alongside a Ferrari, you know, the e-car will get ahead of it, maybe for about the first 2 or 3 seconds, and another Ferrari will take off then, okay? But they are incredible, you know, the ratio, because there's no compression, things don't have to compress at all. You just press the accelerator and this car will take off. What we found ourselves from the use is once you get out onto the motorway, Vernon's other equation, you know, the relationship between drag and V squared, is the one that hits you most. Like wipers on and lights on kind of hit you as well. But like once you go over, there's a kind of a petrol gauge on your electric vehicle that's like a petrol gauge in a car, except it's meant to mean, you know, capacity. And you can almost see it moving, you know, once you're really driving these things very, very fast, you know. And it really bears out the square law relationship between drag. But what's interesting is that an Irish person claims to have found a solution that defies that law of physics, you know. And they emailed us with the solution. They said, if you're out on the motorway, I was saying this to Dennis and Tom earlier, and you get in behind a big truck, okay? and position yourself clearly, that's it, safely back enough. You know, that, you know, if he brakes, you won't end up in the cab. And if you position yourself just, you know, on where the drag, you know, where the wave, if you could imagine the wave, is 0. Like this guy claims that he got his distance, his range, from about 140 up to 220 kilometers. Claims now, and like we can actually test that, like, because every parameter in that car is measurable. Like you take your Nissan Leaf into Nissan tomorrow, they can plug it in and they'll tell you what speed you were going, your rate of charge. They can tell you everything about the car, you know. Now, we obviously can't use that as the solution, like the coefficient of drag won't go away, you know, but, you know, if you're clever enough, you know, you'll find, you know, there are ways and means. So I just thought that would be interesting to share with you. Again, I made the point that, you know, there's hardly a car manufacturer, and again, this is 2011, and Honda now have issued another, or just launched another very, very small kind of city car, 2-seater, and there's a Renault Twizy, which is like a kind of a golf cart type thing that has a windshield but no doors, you know. Again, but it's available for about £8,000, like, and if you're living in the centre of Dublin and you do need to get in and out of work and you do need to spend money on transport, and you want to keep your costs down some way, I'm not sure whether people know or not, but like if we take, say, the Nissan Leaf, okay, does anybody know what the deposit on a Nissan Leaf is? Does anybody know what the average demographic mileage is in Ireland? I can tell you it's 19,000 kilometres, which is 12,000 miles. That's the kind of CSO statistic benchmark that they measure things on. Like, you can drive in Ireland a Nissan Leaf for 19,000 kilometres for €264 a year. A year. If you only charge at home, at night, on night rate electricity. At the moment you can charge in Topaz for free or on street for free, but that'll obviously change. But like the actual unit cost for a night unit of electricity, and you'll use, as I said, at night, maybe about 24 of them. But if you only charge at night, you can avoid the cost or the burden of charging during the day. Like, and lots of people, you know, are spending €100+ now almost just to fill a tank of diesel or petrol. So like, the Nissan Leaf as well, I was asked this outside, you know, probably cost somewhere in the 30 grand. The government incentivised it with a 5k grant, and there's zero VRT, which is worth about another 4. In the last 12 months, the cost of the Nissan Leaf, Nissan have taken another 5k off it, so it is now kind of in the lower half, maybe about 24 grand. Opel plan to launch a car in about 2 years' time, which will be like the Corsa that Vernon mentioned, and that'll be around, I think, 13.5k. And fully electric, like for people, there's a lot. I mean, everybody mentions you can't drive to Dublin or you can't drive to Donegal. Everybody mentions that. But I know, like, there's, you know, most people only drive. I think the other national demographic is somewhere between 40 and 50 kilometres a day on average. And generally, like, your electric vehicle will be eminently suitable for that. So, like, the story has a good bit to play out. I think what was interesting was kind of Vernon's challenges and some of the laws of physics and, you know, some of the honest and honourable attempts to overcome some of them. So maybe we'll see a bit more of that in time. Again, it's hugely interesting from a technology and an Irish location, you know what I mean, in terms of where we're trying to brand Ireland, in terms of being sort of green, but also not just being green, being up there from a kind of an energy point of view and from a technology point of view. Again, this eCar iPhone app is truly amazing. Anybody who's driven one of these electric vehicles has nothing but really, really good things to say about it. We mentioned again on the outside like that, you know, why wouldn't it go full circle? Like, this is kind of where it started. But, you know, I think we all remember an electric bread van or an electric, our kids don't, but I know we do, you know, an electric milk van. You know, the first trains in Ireland were electric. And again, we set out on a project, or in Ireland they set out on a project, you know, to try and do some tests between Dublin and Cork. Now, they never got the full line built at the time, if you know what I mean. And they ended up with a railway that went down as far as Bray. But that worked away fine, you know, and consistent and dependable, you know, for a good number of years, doing about 110 miles a day on batteries. And, you know, where there has been an endeavour to make a project a success, you know, I think people in Ireland have been pretty good at, you know, giving it a good lash. And sadly, I suppose it waned, and like once the diesel engine took off in the early 1900s, you know, it was just impossible to compete. But all the other factors now, kind of around cost, around the environment, around CO2, around, you know, renewable and sustainable living, you know, will bring us back into a very interesting challenge. We set out as part of our programme, you know, to put in charge points nationally. At the moment we're up over 1,000. That covers, now there's still only a couple of hundred electric vehicles. A lot of them are on, you know, trials in homes, in companies, in third level institutions. We have DC chargers in and around Dublin. We have one in Monasterevin. We have ones in Cashel. We have ones in Cork, in Commons Road in Cork. You know, they're going in Limerick. We have ones in Galway, Athlone. So, like, we drove an electric vehicle ourselves, like from Dublin to Cork, from Cork to Limerick, Limerick to Galway, and back to Athlone and back. We did the Cannonball Run, you know, and finished the route, despite all the challenges, with a combination of AC night charging and DC fast charging. So, like, the answers are there. I know there's still, you know, a lot of challenges, but hopefully that will help bring you up to speed on where things are. And thanks for your attention. If there's any questions.
So yeah, I'd like to take some questions off of the
Or
If you start in say a housing estate and people start using these EVs, can the infrastructure handle the charging?
yeah, that's another aspect that's on trial. We have an estate in Dublin in Roebuck Downs where we put a few cars, okay? But like in the limit and in the long term, we know that there will be some challenges in that, and it'll have to be tried and it'll have to be proven. The experience in the US is that, you know, it might bring some transformer overloading problems when all the charging would come on. But like, there's no doubt that you can do a certain amount of it, but it needs to be taken into account in terms of distribution planning and, you know, load profiling and all of that.